Okay, so hi everybody. Today I will present you a characterization of local traffic at home and work. So often when people talk about computer network traffic, they mean wide area traffic like peer-to-peer, video streaming or web. But in fact, there is some traffic that never traverses the wide area. So for example, in this picture you have an enterprise network and a home network. In the enterprise network, all the backup traffic from the enterprise users to the main server will stay inside the network of this enterprise, so it will stay local. And similarly in the home, if a user starts streaming video from a media center, so this traffic will stay local. We, the measurement community, most often study the wide area traffic for two main reasons. So the first reason is that the goal of the studies is to design solutions for backbone networks. And second, if we measure traffic at a backbone link, it will capture a larger user population, and it is hence most representative of users at large. Just previous studies with most of the previous studies with just few exceptions, even collects the traffic at the border of a campus or an enterprise network, or inside the backbone network. So they hence miss all the local traffic. But however, the focus of our paper is on local traffic. So you might ask why. So the reason is that we find local traffic to be different in terms of applications, different in terms of volume and of protocol usage. And consequently, you may ask yourself, why should I care? So the reason is that it is really important for correctly dimensioning and tuning the devices and the software that is intended to be used in the local network, especially the home networks. So how do we collect this local traffic? There is two techniques to collect the local traffic. One is to instrument all the routers inside the local network and to capture packet or flow level traces, similarly to what people have done in the wide area. And this technique is ideal because you can get all the traffic in the local network. But it is hard to instrument for many networks, many different networks, because you need to convince the network administrator and also to have an official approval via an IRB or something similar in each country. The other technique is to directly ask the end host to install a collection tool on their machines. So usually you just ask some friends and family to do these kinds of things. And this technique is really nice because if the users install the tool on their laptops, then just one user is enough to have multiple networks. So for example, if you move from home to work, then we get two networks. But the catch of this technique is that we can sometimes only have a partial view of the users in the local network. So let's say, for example, if we are capturing traffic at home and the user is living alone, so we have all the traffic in the local network. But if this user is connected in an enterprise network of thousands of users, so then we get just a partial view of the traffic. So in this work, the approach that we use is to collect traffic from the end host. So in fact, we use data collected from another project in our group, which is called HostView, that maybe most of you know already about it, and hopefully have installed it. So the HostView tool is an end-host collection tool that takes the perception of the user about network performance. So we use three of the data sets that this tool collects. So the packet header contents, the network environment labels, so the users need to enter the label of the network they are connected to, if it is home, work, or airports, and the application information. So HostView records the process executable names associated with the traffic flows, and we can also get application infos from port numbers using the YANA mapping. This data brings many opportunities, but it also brings challenges. So the first challenge is that host view doesn't give any explicit label to tell us which traffic is local and which is wide area. And worse, it anonymizes the source IP of the local host to protect users' privacy. So we can just match the prefix of the local IP and the remote hosts. And second, users may not enter the environment label. They have something else to do. And host view also asks for the labeling for the Wi-Fi network, so not for the wire. And finally, the users use a really large set of applications that do the same thing. For example, Outlook or Thunderbird, they are doing email, and uTorrent are doing peer-to-peer. So this is really diverse, and it's hard to compare at the end. So to address all these issues, we developed a number of heuristics to post-process the data for our analysis. So to address the first issue, we try to separate the local traffic from the wide area traffic by considering all the flows between the local host and the private IPs as local traffic. Of course, it is too simple, and we enhance this heuristic for taking care of the carrier-grade nets, because it's a different processing then. Second, trying to address the missing labels, we manually inspect the ISPs. And for example, let's say if we have one trace unlabeled that contains University of Pierre and Marie Curie, so for us it's work. And another trace is containing Telefonica, so for us it's home. And finally, we group all the applications according to high-level categories, 11 categories in our case, to be simple to compare at the end. So for example, we group all the flows from Safari, Mozilla as well. So we apply this method to our host view data collected from 47 users. Each user ran host view for at least a week. And overall, we could get 185 different networks from 18 countries. So this data is biased toward expert users. So it's only available for macOS and Linux. And it was advertised at conferences and via mailing lists. So the work environment is often universities. And another issue is that the researchers can also work from home. Actually, they work a lot from home. So in the application mix of the home, we can find some applications from work. But still, with all these biases, we do find a lot of diversity in our data when we analyze it, and we could study 185 different networks. So we try with this data to ask 3 basic questions. So the first one is, how does the volume of an end-host local traffic compare to its wide area traffic? So this question is important because nowadays there is some models available for the wide area traffic. The question is, are these models also hold for the local traffic? And by answering this question, we can help by mentioning the network equipment that is intended to be used in the local networks. Then what about the applications in the local and the wide area traffic? So it is important to know which applications need to be supported in local networks, as each application have a different requirements. So, so for example, if we have a security applications, and so there is no need to fine-tune, for example, a chat analyzer if there is no chat traffic in this local network. And finally, how does traffic vary between the home and the work? So in the previous work, the enterprise network had received a bit more attention than the home networks. So can we apply the enterprise solutions to the home also, or is the home local traffic too different? So trying to address the first question, let's look at this figure. So this figure represents 4 different classes of traffic. The wide area traffic split in TCP and UDP, and the same for the local traffic. Each bar represents one user, and the y-axis represents the percentage of the user traffic volume in bytes. So here we have an example of one user. So we can see that all the local traffic of the user is TCP up to 50%. And the wide area traffic of this user is composed of 42% of TCP and 13% of UDP. So now let's look at the 47 users. So we ordered them from least to most local traffic. And it is obvious that the blue part is dominating in this figure. So which means that the internet traffic, so the wide area traffic, is dominating the local traffic. In fact, we had overall, including all the users, 3 terabytes of wide area traffic compared to only 780 gig for the local one. Another result is that almost all the bytes are transferred in TCP connections. So we have almost 90% of the bytes transferred in TCP, which is also the same case with the previous findings. Finally, half of the users only exchange traffic with wide area hosts. So we can see that in here from this figure. And also, you can note that this rightmost users transfer more bytes locally than wide area. And when we dig into that, it is mainly network file system. So maybe users are just watching videos or listening to music from a network storage. And then what about the application mix for the local and the wide area traffic? So this figure represents the distribution of our 11 categories plus the unclassified traffic, so the traffic that we couldn't classify, which doesn't exceed 7%. And the y-axis represents the percentage of each category in bytes. So here, for example, we can see that locally, network file system is representing 65%. So for the wide area traffic, so we see typical application distribution with the web and peer-to-peer being the top applications. So this corroborates the previous findings of the wide area traffic studies. For example, a paper from SICOM 2010 from Labovitz or Meyer IMC 2009. And we can also see some distant control and fire transfer here. It also, looking at the previous studies, it also makes us more confident about our user population that is fairly normal in terms of application distribution. When we look at the local traffic, it is different significantly. So we can't almost see no category where the red bars and the blue bars are equal. And we see in the local traffic that the network file system and the backup are the most dominating applications, and they don't appear in the wide area. And in contrary, the web and the peer-to-peer are present in the wide area and doesn't appear in the local traffic. So now that we looked at the aggregated traffic and separating the local from the wide area, let's look at the different environments. So in this work, we focus on the home and the work environments only because they contribute of 98% of all the local bytes that we have in our data. So this plot is roughly the same as the previous one, but now we try to compare the home and the work local traffic. So it's a breakdown from the red plot that we saw previously. So in here, we can see that the network file system is even more dominant at home. So, for example, IFP and SMB. And we can notice also that the name service is also pretty high in terms of bytes in home. And for the work case, we also have some web and email. So in contrary of previous studies that has a lot of web and email, so here we have just a little web and email, but this difference might be due to our users that are mobile, in contrary of the other users of the previous studies that were in the enterprise with fixed machines. So after this study, we can try to answer our previous questions. So how does the wide area volume looks compared to the local? So the wide area is dominating. What about the application mix? So the web and the peer-to-peer are dominating in the wide area, while in the local we see a lot of backup and NFS. And what the difference in home and work in terms of applications, so we see a lot of backup and file transfer at work, but they don't exist at home. And we also notice a little email and web at work. So that's it. And if you have any questions.
Yeah, I have one question on the kind of methodology of how you will bound and found kind of error rates on the heuristic you gave. You need to differentiate the local and the wide area network.
Mm-hmm. So for example, looking into our data, we noticed that there is some cases that our heuristic can be false. So for example, if you're using a NAT at home, so all the private IPs, so it doesn't make sense to bound the local traffic to all the private IPs. So then we developed another heuristic. Maybe we can explain it if we have more time later. And also there is a case also in the work where people are connected to the local networks, but they are using public IPs. So for this case, we also developed a third heuristic that takes care of this.
Okay. So you took this into account? I mean,
yeah, exactly. It's not as simple as, I mean, it's too complicated to end up with 47.
And the other side of the question is, you have 47 users on this. So generate how it could reflect. I mean, in more general sense, and all users.
You mean what is the scale? What is the scope of the study regarding?
Yeah, what could be a way to generalize that or not?
Yeah. So in our data, we don't say that this is the shape of all the local homes and all the local work. I mean, we admit that there is it's really few users, but the fact is that this data is hard to get. So what we could get, I think it's representative because in the wide area studies, we could, with our user population, corroborate what they find. So as there is no previous studies in the local network, we assume that it is pretty correct. But then the thing to do is maybe to have a larger time collection first, because it was 1 week. Actually, 32 users have 1 month of data collection, but it's still not a lot. And to get an overview of the traffic in a local network. So for example, for our future work, we are focusing on home networks. So we want to be able to do that from the gateway, to have all the traffic crossing the home, and not only a per user and partial.
So I was surprised by one of your results, which was no wide area backup traffic. Because I thought that services like, so you say you have Mac users, iCloud, or Dropbox, also I think a very popular service. I would think if those were present, they would account for a large number of bytes, and I thought that they tended to be rather popular.
So maybe it's a matter of classification in the categories. So for us, Dropbox was classified as file transfer, in the file transfer category. So we see a bit of file transfer. And actually, when we did something that I didn't mention, when we did the local traffic study, we saw that Dropbox appears in the file transfer, which is surprising because we didn't expect it to appear in the local traffic. But it turns out that Dropbox is using a direct connection to synchronize all the devices in the same subnet, so that's why we find it also in local.
So it could well be that another device in the local network that you're not monitoring is doing the wide area part of Dropbox, and the host that you're bringing in is just doing the local.
Exactly. So something that is maybe missing with this data is that there is some services that the end host doesn't generate and doesn't consume. So it never sees this. I mean, if we are using a media server that streams video to a TV, so it doesn't have something to do with the end host, so maybe we're missing also this traffic.
So Cisco says that currently 50% of traffic is video, and is that buried inside your web traffic because it's mostly HTTP streaming, or?
So in the web traffic, we don't make a difference. I mean, we could make a difference between what is video and actually the girl which is taking care of host view dig into that and try to also see the high-level domains and see which are the popular websites and things. But we don't go like into these details. We just look at its web and it's fair for us.
I guess video would also have large transfer sizes where where it's just one browser would be really short.
Yeah.
Have you thought of how you can use these video results in tuning the devices, which is part of your motivation? How you can use your device, the one you own? Your research. No, your results.
Okay.
How can you use your results in tuning the devices?
So, as I said previously, if we want to tune the local networks, we need to know which are the popular applications in the local network. And I think that the range of applications we find and the importance, more or less, of each applications can help tune the equipment to sustain depending on which kind of traffic. If we need to sustain file transfer, it's different than media streaming, and the requirements are different. So I think that the picture, it gives a good picture for tuning the device.
Could you have a similar picture with just a questionnaire? I am curious if there are already studies with simple questionnaires that the users might reply, and if from this we would have a little bit the same picture.
Oh, I see. Like these are the applications, and do you agree with
yes, which applications do you use more often? Do you use? I mean, are there such studies?
Just to correct, I don't know if there is. I saw once that there was. There was a kind of statistics of what people are using. I think it was related to the Home Maestro project, which is a project when you plug a tool to control the bandwidth in your home. And before that, people did a survey asking which are the popular applications. But it depends a lot on the user population.
As yours.
Yeah, exactly. But our user population is a researcher. Maybe I should do a formula only for laptop.
A philosophical and a technical question. So the philosophical one is, it's rather surprising not to see any kind of backup at home, but if you look at the percentage of network file system traffic, you see that the home is much larger than work, and surprisingly is about the same amount with respect to the backup to the work. So would it be that in the way you define the heuristic, you are classifying something like backup in work because you're using a specific protocol like rsync or whatever, and in the other case you're just using plain NFS to copy your data, but since you're not looking at what data is copied, then you just are not aware that part of that NFS traffic is backup. This is the philosophical one. And then the technical one is surprisingly high percentage of name service. So you point this out, but what does it mean? I mean, your users are macOS and Linux geek. So how come that about 10% of the traffic is name server at the home? What does it mean?
Okay. So for remember correctly. So for your first question, so I agree that the way we classify the categories, it's not as subjective, but it could be because, for example, we have this miss category at the end because there was some things that we were not sure about, so they are doing pretty a lot of things, so we didn't know where to put them. So we put them in the miss category. But then I think that network file system, when we were looking at the applications and looking really at the data, it was applications like iTunes or transferring files, and I don't think that there was a lot of things related to backup, but maybe I missed something because I can't really manually check all the traces.
Time machine?
The time machine would be classified like backup, in my mind, right? Because it's backuping your data. It's doing backup, automatic backup. So how can you? So my question was about can you give a label that was meaning is different in work and home just because the heuristics are not able to find really differentiate between this kind of traffic.
Can I just answer one thing? It's just like, this is 1 week of data too. I mean, I don't know how often you guys do time machine. I don't do that. I don't do it once per week. So we might just not get the good week.
I think a lot of people have it on automatic. So whenever the disk is present, it starts going.
Yeah, but you have to put the disk. And that's not network.
If it's on your home network.
Yeah. I don't know.
And we explained the lack of backup traffic at home by the fact that maybe users, when they are at home, they prefer to use external USB storage rather than using backup over the network. So that's my
And then service.
And name service. So I was looking into that, and so trying to look at people that complains about having high name service at the home. So I found that there is like some cloud antivirus and some cloud services in the internet that requires name service request or something. So that might be a reason, but then I mean there is not actually a real. I mean in our traces we don't have a real manner to know exactly in fact what is happening.
So it could be that your name service traffic is coupled with all the other traffic. So for every connection you make a lookup. So it's coupled with the external traffic too.
I can look into it. So maybe.
So we're still expecting some questions if you have. So we can move to the speaker.